Hello and welcome, my name is Sven, and if you're interested in what are the most common vulnerabilities in web apps, then this is exactly the right one for you, and stay tuned. One of the most common vulnerabilities of web apps is cross-site scripting. And this attack, how it works and why we're calling it cross-site scripting. So cross-site is meaning that you are inside the same web application and you have a context you trust and a context you don't trust. And scripting is coming from the technology itself, so mostly script languages are involved in this kind of attack. So this is why we have this cross-site scripting. So how does this cross-site scripting attack work? So mostly it's some kind of HTML injection or some JavaScript injection. So it means you try to identify what part is dynamically executed, for example, and try to push some content there. It could be, for example, session hijacking, so that you try to get the session information and try to reuse this old session. It could be in a way that you are just using data that's transmitted and try to execute actions as a different user. So more or less this cross-site scripting attack is getting content into this trusted context and hope that's executed. What is a non-persistent cross-site scripting attack? A non-persistent cross-site scripting attack is more or less non-persistent, because if you have an attack, you're doing it right now, but if you are using this application later, then this attack is not there anymore. So how it works, so someone tried to give you a return type from the server that is compromised, so that it will be executed on your side. But with the next request, everything is more or less clean again. So this is a non-persistent cross-site scripting attack. What is a persistent cross-site scripting attack? A persistent cross-site scripting attack is based on something that's really stored on the server that you're consuming. So you're requesting something from a server, and that compromised file is already on this server. So it will be delivered every time, not during the attack you are facing right now. It's really part of the server now, and this is a persistent cross-site scripting attack, and this is way heavier than the non-persistent one, because this is just existing until this file is deleted on the server side. A different version of this cross-site scripting attack that not even needs the server at all is a DOM cross-site scripting attack. This is in a way that DOM inside the browser is directly manipulated from outside, and there is no round trip, there is no manipulation of the server in itself needed. So with this, you're just manipulating inside the browser the context and try to execute their stuff. So this is really a browser-only attack. There is another variant of this cross-site scripting attack, and it's called the self-cross-site scripting attack. The self-cross-site scripting attack is in a way that the attacker is not manipulating the system itself, but he tried to influence you as a human in a way that you are doing some stuff. It could be sending you an email and asking you for whatever, to do something, or to change your passwords, or all this paging stuff, for example, is going that way. And this cross-site scripting attack involves you as a human, and someone is trying to manipulate you so that you are doing it in your context. Okay, one of the next versions of this cross-site scripting attack is a mutated one. The mutated means that on the first view, the data you're consuming looks okay. So it could be in PDF and it looks valid. But inside the PDF header, you have JavaScript embedded, and then you're executing stuff. So the mutated one is getting data that looks valid, but during the execution, it will show its right face and will try to manipulate your system. One really common vulnerability is SQL injection. What does it mean and how it works? So SQL injection is more or less based on the SQL backend. So you have some web server, or you have some backend that's consuming SQL. And what you try is that you inject data in a way that the SQL command that should be executed is modified to a compromised version. It could be with different escaping techniques or whatever. So you have different ways to manipulate SQL in a way that you can compromise data. So you can delete data, manipulate data, you can even try to extract data that you shouldn't be aware of. And yeah, this is a SQL injection. What is a typical thing, how it works? A typical thing is, for example, you have a web application and you have some text input fields. And the text input field, you're not adding in 1 or 2 or whatever data is just requested. You start adding partially valid SQL and hope that on the backend side, during the consummation or during creating the final SQL string, this partially provided SQL will be added in a way that the behavior is exactly like you want, so the compromised behavior. One vulnerability that's mostly underestimated is path disclosure. What is a path disclosure? It means that you have the knowledge about the paths of the web server, so you know where you are and what are the other paths in this web system or web server. What you can do with this is that you can use system libraries with load file or whatever, because you have the direct knowledge. You can work with direct paths, and this is the base for a bunch of other vulnerabilities. So one vulnerability or one attack is a denial of service. It means that you try to make a system unavailable. It could be a service, it could be a part of an infrastructure, it could be public infrastructure, it could be hardware, it could be software. So, well, the target is that you're making some service unavailable. And talking about web systems, this is mostly used for different reasons. It could be just to get some money, it could be to make a service during trading hours slower or even unavailable to have an economic damage. It could be during political events to isolate different parties or whatever. So you have different reasons. It could be from a single person, from hacker groups, or even from governments. So even governments are using this way to make services unavailable. So you have two different flavors of this. It's a temporary one and you have the permanent one. The temporary one is just for a few hours, days or weeks, whatever you can afford or you want to reach or whatever. And the other one is really you try to destroy. Destroying could mean that you try to destroy the hardware. You can encrypt the systems in a way that it's unusable or unrecoverable, so that you really have to reinstall the infrastructure. Whatever it means, most attacks, denial of service attacks, are distributed ones based on botnets. And yeah, well, denial of service attack, one of the famous ones. One vulnerability is called code execution. But why code execution and what happened with code execution? So, looking at the architecture of most computers is that you have some instruction pointer or some instruction counter. And what happened is that it's just increasing until there's a jump or a branch, and then it will jump to the next address, and then it will start executing what is in the memory. The weak point here is that most older architectures don't have this no execute flag. They don't have it, and it means that data and instructions are just the same in memory, just bytes. And if you have now the possibility to change the value of this instruction pointer, then you can just load some stuff what you want to execute somewhere in memory, and switching with the next instruction, jump to exactly this part of the memory, and then it will be just executed. And this is the vulnerability code execution. Another vulnerability is memory corruption. So what does it mean and how it works? Memory corruption is mostly accidentally happening. So if you have programming languages where you can address and allocate memory manually, and you don't have safety mechanisms like this garbage collection mechanism like in Java. So what happened is that you're allocating a certain amount of memory, and then you're consuming it, and inside your logic is a mistake, a bug, whatever, and you're going over this border. So what you're doing here is you're consuming memory that was never intended to be used by you, or you're overwriting some other memory, and some other programs are just reading garbage out of it after they started executing again. So memory corruption is one vulnerability, and you have to make sure that you're using memory allocation very safely, or you're using programming languages that will do exactly this one for you. But even in Java, you can mess up the system if you're going off heap, because it's exactly this one. You're going around this memory allocation safety mechanism that is consuming some time and resources. You're very fast, but the trade-off is, if you're doing a mistake, if you're doing it wrong, then you're crashing the whole JVM. So that's it with memory corruption. Okay, it's time for the conclusion. We saw a bunch of different vulnerabilities and they are so common. So it's really necessary that you're working against them and check your system if maybe some of this vulnerability are possible there. So if you're interested in more detailed information for some dedicated vulnerabilities, just let me know and write it down in the comments. Ask me. You can ask me via LinkedIn, Twitter, here on YouTube. Feel free. And I would like to get some feedback if you like this topic, if you want to hear more about this one. Otherwise, please subscribe my channel, turn the bell on, and my day is done. I will now explore a little bit the rest of the forest, and then it's time to go home. And whatever day or time you're looking at this video, enjoy it, stay safe, and see you on my channel.